You're wearing a tennis shoe on your head. No, okay. All right. And let's get this set up. And we'll go from current slide. All right. Are Joanne and John are the only two here?
No.
Who? Oh.
John.
Who is?
Kyle.
I can't hear.
Kyle.
Kyle. Oh, welcome, Kyle. Okay. Kyle, are you in Brunswick?
Yes, sir.
All right. It's 11 o'clock class for you, isn't it?
Yeah, I get a little bit more sleep. It's
Huh?
okay. I get a little bit more sleep, but I'm not going to complain.
Excellent, excellent. Okay. Anyone else? I got 3 here. Do y'all see any others on the screen? I have so many things open, I can't see everybody. I can only see 2 names at a time. All right. I almost thought I heard JJ, did I? Is that JJ? No, who?
Hello.
Oh, okay, great.
Hello.
Jermanuel, right?
Yes.
Okay. Is anyone else showing? Houston, excellent. Good to hear you. If I can't see you. Okay. Who is it that's hired somebody to do all their different voices? No, you wouldn't do that. Okay. All right. So I've got 5 so far. Does anyone see any more than 5? Okay, 5 going once, 5 going twice. Okay, let's hit it then. Don't know of any major new announcements. I think we made them all last time, but all of you weren't here last time, so let me go over a few of those. I think I'll wait until more people show up before I hit one of these things, but you know that we are not going back to campus next week, right? Everybody knew that. Yes or no?
Yes.
Okay. Originally, they had said we'd be home through now and going back next week. Not going to happen. We're going to be virtual class for the rest of this term. And Houston is smiling like he is so happy about that. He likes the extra sleep too, okay? All right. I just happened to get your picture up. Okay. Probably the rest of you are smiling too. Okay. All right. Then, did you also know that we are doing virtual classes this summer as well? Had y'all heard that?
I did not know that.
Okay, that is that came out over the weekend, and the president sent a letter sometime Monday, I think it was, or somebody sent a letter, maybe Miss Albright. Okay, is that someone new in the class there? No, that's Jermanuel, right? Okay. Jermanuel's got a bright light behind him. He must have done really well. Okay. There, I see. Okay. It looks like he's the favored child here. Okay. The sunlight's beaming down on him. His chosen one. Okay, got it. All right.
He was here.
Say again?
Andy said he was here.
Andy's here. Welcome, Andy. All right. So that gives me 6. I think that may be a new indoor record for the online class. It seems like the most no, I think we had another day with 6. Okay. One day.
Carlos here.
What's that?
Carlos.
Carlos is here? Excellent. Way to go, Carlos. Welcome. Now it's a new indoor record, okay? Because I don't think we've had 7 in this class before online. Or, I'm sorry. These are virtual classes. Online classes are the ones that you don't have to show up at any particular time. You just do the work. Virtual classes are the ones we meet at a certain time and we see each other and interact. That's what we're doing this summer, are virtual classes just like this one. Now, there will be a few classes offered online, the same ones that originally, but those are all, in math anyway, Math 100, 112, and 110. Those are the only ones being offered online. but the rest are being offered virtually, just like this one. Are any of you coming this summer?
I thought about it at first, but
You don't like these classes? It's what?
it's gonna be a lot harder to learn math virtually instead of actually physically there. I'm graduating this semester.
Okay, that was Jonah, right?
That was you. Yeah.
And who else? Jemanuel, you too? Oh, no. Okay. I thought you said that. All right. Well, the registration will be opening for summer term sometime later this week, they claim. Now, I don't know how they're going to do that because they're monkeying with the schedules like crazy trying to make all the adjustments. So I've got a phone call tonight around 6 or 6:30 that's probably going to go for an hour or more on working on the schedules. So we'll try to have it out there by the end of the week. All right. Any other questions about anything? One thing that I know, I hope is coming up soon, I haven't heard anything about it, student course evaluations. Please do those too. Those are still very important for us to do. I haven't heard they opened them yet, but keep watching. One other thing, okay? I saw an email this morning that was sent to all students, so you got it too, that was talking about the virtual tutoring center, the Space Center, some of the other places, all the things that we're offering before. I put on your blackboard also something about the library. Everything's open as normal, but it's all virtual. So you can get tutoring virtually, you can do everything. You can get your advising virtually. Now, I don't know if we can actually register you for classes. You may have to do that yourself, but you can get all the advising that you need. I haven't figured out if the system will work if you're on Zoom and advise. I don't know how much will work at the same time, but you can get advising online. So everything we were offering before that can possibly be done, we're doing that now. They're working on how do you do payments. Of course, anyone who's on Pell Grant, all you have to do is complete registration. If you got enough money in Pell Grant, complete registration, you're done. However, if you're paying any other way, the easiest thing is with a credit card. Okay? If you don't happen to have a credit card, or it may be approaching its limit or something like that, but you have another way to pay, I'm sure they will accept checks, but I don't know if there's a window open. You may have to mail them. I would say contact the business office by phone or by email or something like that and work out how you can do your payments. I asked that question at a meeting last night, and no one seemed to have thought about it before, so they're working on figuring out answers to that now. All right. Do any of you have any questions about how this virtual life is going to continue? All right, ready for calculus then. I know you've been waiting for me to quit talking about this stuff so you can get to calculus. I can see it on your faces. Okay. All right. Where we left off last time, if there's no more questions, we're in Chapter 4, Application of Differentiation. And last time we got started or continued in, I think we got started in 4.3, increasing and decreasing functions and the first derivative test. And that's what's on the screen right now, Theorem 4.6, which is the first derivative test. Now, I know a lot of you weren't here last time, so hopefully you've watched the YouTube videos. Yes, I can tell you have, and you understood them fully, and because you didn't have any more questions about them. Is that right? Okay, I see beats. Okay, never mind. All right. So, let's then get going with first derivative test. Now, let's start with a little bit of review. What in the world is a critical number? If you have a function, how do you determine what the critical numbers are? What's the first step? You're given a function, f of x. Okay, a little louder. Take a derivative. Now, who is it that said that? That sounded like JJ, was it?
Yes, sir.
It was?
Yes, sir.
Okay. I didn't hear you come on, so I wondered where you were. Sleeping in, I figured, but okay. Oh, and today is April the 1st. April Fool's Day, okay? I was going to say we canceled class today, but I was afraid you would all log off before I could say April Fools. Okay. Yeah, I can tell. Okay. Okay, we're just missing Christian and Devante.
Dr. Fowler,
Yes.
you said you were going to email test 2 out, and I still haven't got that test yet.
Say that one more time.
I still haven't got test 2 yet.
Have we, test 2? Yes, I emailed, okay. Yes, I sent, for those who were in class before we left, I gave it, and then that Monday we were there, and then I emailed it to everybody. I sent it through messages. Have you checked your Blackboard messages? Okay.
I don't think I checked my Blackboard messages.
Okay.
Stay on top of those.
What's that?
So you better stay on top of those.
Something on top of those. Oh, you got to stay on top of those, right? Okay, gotcha. My hearing's so terrible. You should hear me on the Skype Zoom with the dean. I'm having her repeat everything she says because her frequency is just not one I pick up well. In many ways. No, I didn't say that. Okay, never mind. So we're missing Christian. He hasn't made an online presentation yet. Does anyone have any information on him? Interact with him at all? Okay. And then Devante is the other. He hasn't made any online yet. He was there that last day of class, and he hasn't been on any of this is the third virtual class we've had. So does anyone?
I'm texting you right now.
Okay, excellent. Thank you. And
I was fixing my audio, that's why I didn't ask questions.
okay, what I started doing was telling about these Zoom sessions by announcement, and then I found the message thing, and I thought that was just a shortcut to the announcement, so I started doing it on that, and then I was told, I think Kyle said he couldn't find it, and he was looking on the announcement, so I started putting them on both. So you'll see it on the announcement, and you'll see it on the messaging. So, yeah, if you could spread that word around to anyone that you know, appreciate it. I also need to know if someone's not getting those because this new Blackboard isn't working as well as the old did. So I can't tell if it's its fault, the student's receipt is bad. I just don't know. And I have no way of finding out because I can't get in touch with them. So thanks for texting him. All right. Any other questions? Okay.
I had one.
Okay, what's that?
I was trying to ask you a while ago when you said the first time you had questions, but I got an email saying that we'll get a refund, but I'm very confused about what.
Okay, what were you getting a refund for?
I don't know. Let me get the email.
That's direct deposit of student refunds.
It's what?
It says direct deposit of student refunds. Like, what is that?
I don't know. Okay,
Well, they still giving out payout.
say that again.
But the people that's getting payout back, they still giving them out.
Okay, something about Pell. Did y'all understand it? Because I probably need to know it so I will know if anyone else has this question. So what was it about the refund that?
They said they still giving out payout every week for the ones that are receiving it.
Oh, I didn't know you got Pell every week. Maybe I need to sign up. No, I'm just kidding.
They changed that.
The what?
I think they just changed that now. Every other week is scheduled. You can pay it back
Oh, okay.
for the remainder of the semester.
All right. Does that answer the question? Because I don't know beans about how they handle the money. Unless they don't pay me, and then I get really upset. Okay. I'll be upset if they don't pay you too, but my wife gets upset if they don't pay me. Okay, so I get upset. All right. Any other questions? That's a good one. I just don't know the answer. What you can do if you have questions like this, either email or call the business office. Now, I have heard that the business office is occasionally has someone there on campus, so you can try to give a call. They're not there every day. They are not publishing when they're there because they're trying to maintain the social distancing, but they sometimes have to go in to take care of things they can't do at home. So you can always either try to give a call or email. And I think I heard last night there was actually an email that says business office, one word, at lawsonstate.edu. So if you don't know who to contact, just do business office at lawsonstate.edu. Don't put any spaces, don't put any underlines or anything else. Just business office at lawsonstate.edu. And I think a lot of the things like records, you can just do records at lawsonstate.edu. Hey, finally I got to see JJ. Okay. I'm not sure I'm happy. No, I'm sorry. I didn't say that. Okay. All right. Any other questions? Good questions, by the way. All right. Now, I did hear an answer. I think it was JJ that said, how do you find a critical number? The first step is take a derivative of that function. The derivative itself will not just let you know, hey, I'm a critical number. What is it that makes a critical number critical? What is it about that first derivative?
Where
Exactly, where it's either equal to 0 or where it does not exist. Those are the two cases that would make a critical number, okay? Where the first derivative is 0 or does not exist. Now, so this theorem starts off with, let C be a critical number of the function f that is continuous on an open interval I that contains that critical number C, okay? If f is differentiable on that interval, okay, except possibly at C, because remember, the first derivative may not exist there. That could be a critical number, so it may not be differentiable at C. Then f of C can be classified as one of the following three possibilities. Okay, and this is what we were talking about before. Here again, we go to that first derivative. If that first derivative changes from being negative on one side of that critical number, I'm using the wrong pen. Okay, I was wondering why it wasn't showing up. Okay. All right. If the first derivative is negative on one side of that critical number C, but is positive on the other side, then that makes that critical number of what? Relative minimum. You see? If, however, the first derivative changes from positive on the left to negative on the right, that makes the critical number a relative maximum. I didn't mean to cross it out. Okay, relative maximum. But you have one other possibility. If the first derivative is positive on both sides or negative on both sides of that critical number, then this f of C is neither a relative maximum or a relative minimum. Neither one. Okay? So just the fact that it's a critical number does not guarantee you have an extreme value. Okay? A relative extrema. For it to be a relative extrema, the first derivative is always either 0 or doesn't exist at the critical number, right? That's what makes it a critical number. But if it changes sign there, it goes from plus to minus, or, minus to plus or plus to minus, then you do have a relative extremum. Okay? It's a relative minimum if it goes from minus to plus. It's a relative maximum if it goes from plus to minus. But if it doesn't change signs on either side of that critical value, it's positive, positive, or negative, negative, then It's neither a relative minimum or a relative maximum. Because on these two, the first derivative is also 0. That's what made it a critical number. All right, does that make sense? So that's the first derivative test. Number one, you test it to see if it's a critical number. If that first derivative is 0 or if it doesn't exist. Secondly, you use something to the left, something to the right, stand up, sit down, fight. No, that's a different thing. Okay, if it's positive to the left, negative to the right, relative maximum. Negative to the left, positive to the right, relative minimum. Okay, but if it's positive on both sides of that critical number or negative on both sides, it's a neither. Neither relative minimum or maximum. Does that make sense? Beat it to death, huh? All right. Here's example 2. Flip a page to page 224. Applying the first derivative test. Okay. You thought you already had the first derivative test, but that was no. Well, never mind. All right. Find the relative extrema of this function, f of x. Guess what we're going to do first? Take a derivative. Oh, what is the derivative of that one? Anybody? 1/2 is the first. A little louder. Minus. You may have said it, I didn't hear it. Cosine x. Perfect. Okay. Now, I'm cut off here. I think it says in the interval from 0 to 2 pi. And that's the open interval, 0 to 2 pi. So we need to find what in that open interval? Places where the first derivative is. Say again? 0 or does not exist. So let's start with 0. Let's take that first derivative, 1/2 minus cosine x, and set it equal to 0. Okay? What are you going to do with that? I wish I'd have left it on the other side. Let me do that. Okay? It's silly, but I'm just going to do it that way. Okay? I'm going to put the 0 here and do 1/2 minus cosine x. Some of you may see why I did that. Okay? What you need to do to find the zeros of that first derivative? First step. Add cosine x to both sides. You're trying to isolate the cosine x. Okay? Okay, that gives you a cosine x on the left is equal to, these add to 0, 1/2. Now the question is, for what values of x, and these are radian values, in the interval from 0 to 2 pi is the cosine 1/2? Anyone know that? Okay. That is one of our favorite angles, by the way, that you knew and loved from trig class. I remember that many of you knew and loved it dearly, okay? Do you remember how we did? I'm going to do sort of a unit circle here. I don't do circles well. I don't do axes well either, do I? Okay, here are those favorite ones. When theta is equal to 0, of course you're right here, okay? When theta is equal to pi 6, you're right there. When that's not very good. This is theta equal to pi 4ths. This is theta equal to pi 3rds. They should be evenly spaced. They're not. Okay, and this is, of course, theta equal to pi 1/2. Those are our favorite angles, remember? We know and love them well. I'm going to fix the pi 4ths a little bit because that's bugging me. Okay, and the pi 6 isn't good either. I mean, pi something like that. Okay, that's pi 4ths. All right. Now I'm going to give you the way I remember these, though I use them enough that I know. But I'm going to first do the sign. The sine of these angles, sine of 0, of course, is 0. Sine of pi 6 is the square root, and this is the square root of 0 over 2, by the way. Pi 6 is the square root of 1 over 2. Pi fourths is the square root of 2 over 2. Now, these are the sine values. Pi thirds is the square root of 3 over 2, and pi halves is the square root of 4 over 2. That's pretty easy to remember, isn't it? This is just 0, this is just 1/2, and this is square root of 2 over 2, that's square root of 3 over 2, and this, of course, is square root of 4 is 2 over 2 is 1. Okay? Pretty easy to remember. Those are the sines. The cosine goes in the reverse order. Down here, it's 1. I'm going to put cosine in a different color. Y'all choose a color for me. Which? Red. Okay. I'll choose red if I can get red to come up. Come on, red. You can do it. Well, maybe it can't. There it goes. Okay. So the cosine would then be 1 here. Let me start up here. 0 up here. 1/2 here. Square root of 2 over 2, that's the same. And this would be square root of 3 over 2 here. It just is reverse of those. So the question now is where at least one value is the cosine x 1/2. Right there, pi thirds. You see it? So there's one place, x equal pi thirds. Now the question is, between 0 and 2 pi, is that the only place where cosine x is equal to 1/3? Okay, someone think of another one? Okay, here's another question. How do we define cosine anyway, especially when you're using the terms x, y, and r? Do you remember that? How is cosine defined with regard to x, y, and r, where r is the hypotenuse of the radius? Anyone remember? Cosine x is equal to, how about some old hen caught another hen, taking oats away? Y'all ever hear that one? No. Some old n is sine is opposite over hypotenuse. Caught another hen is cosine is adjacent over hypotenuse. And taking oats away is tangent is equal to opposite over adjacent. Didn't hear that one, huh? You must not have had a poor trig teacher like I was. Okay, so here your opposite side is your y, your adjacent side is the x. So cosine is adjacent over hypotenuse. Caught another hen. Okay, now if the cosine is 1/2, that means the x value has to be a 1. Over here, the x values are -1. This isn't a unit circle anymore. This is a 2-circle now. Okay? Okay? That makes for your derivatives, your denominators always be in your radius. So that's a little easier to deal with. So, frankly, the cosine cannot be a positive number in the second and third quadrants. Can it? Okay? Remember this one? All students take calculus. Ever hear that one? Or chemistry, or All-State Technical College, or whatever you want to call it. These are the basic trig functions where they're positive. All of your trig functions are positive in the first quadrant. Only the sine and its reciprocal, which is cosecant, are positive in the second quadrant. Only the tangent and its reciprocal, which is cotangent, are positive in the third quadrant. And only the cosine and its reciprocal secant are positive in the fourth quadrant. So cosine's positive down there too. Well, the adjacent side needs to be 1, while the radius is 2 to give you a 1/2. And where would that be? If this was pi thirds up here, then this must be a pi thirds down here, right? Okay? And if that's the case, you're 1/3 pi short of 2 pi. Well, 2 pi is how many thirds? 6 pi over 3? Isn't that 2 pi? Subtract 1/3 from that, and what do you get? 1/3 pi? Just like we had a pi over 3 up here, you get 5/3 pi. So that's the angle here between 0 and 2 pi, the other angle. X equal pi thirds, that was supposed to be a pi, not a 1/3. X equal pi thirds and x equal 5 pi thirds. Okay? All that was to find out where the first derivative is equal to 0. That was half of a trig class, wasn't it? Does it make sense? Ringing any bells or giving you headaches?
Headaches.
Oh, I'm sorry. Not too. Oh, okay. All right. So these are the two places for x where your first derivative is equal to 0. Now, I need to erase most of this mess so I can write the rest of it. Are y'all okay with that? Okay. Review that trig, folks. You're going to be using it big time. Okay? Okay. All right. Okay. All right, to erase that part too. Okay. Yeah. Okay. That was just step 1. Or part of step 1. What's the other place where you could have a first derivative? I mean, where you could have a critical numbers. These are now your critical numbers. I called them X here. They're actually can be called C now. Okay? What's the other condition that could be a critical number? Where the first derivative is 0 or where it does not exist. 1/2 exists everywhere, okay? So that's no problem. Cosine x, any limitations there? No, cosine x exists everywhere. If you drew the function for cosine x, which you did in trig class, it goes like this and like this and like this and like this. It's everywhere, okay? So there's no place where that first derivative doesn't exist. Now, if that had been a secant x, oh, yeah, there's a lot of places where it doesn't exist. At least 2 between 0 and 2 pi where it wouldn't exist. I can't get my eraser to come up. Okay. All right. So we've done the second part. That was much easier. First derivative exists everywhere, so it's only the 2 critical values are where it's equal to 0. First derivative is equal to 0. So what else do we need to do here to find the relative extrema? We don't know those are relative extrema. Actually, my graph I just had on there indicates they probably are. But how do you find them analytically? What's the other conditions for relative extrema? I'm not going to draw the graph, but it looks like I am. I'm just doing from 0 to 2 pi. Okay? So there's pi. There's pi thirds. There's pi what am I doing? That was pi 6. No, 2/3 pi. That's what I was doing. This is 4/3 pi. Because this is 1/3 pi, 2/3 pi, 3/3 pi is 1, 4/3 pi, 5/3 pi. And 2 pi is 6/3 pi, right? So there is our number line. We're going from 0 to 2 pi. Not going to reach either one of those. Okay. So what we need to do here is what? Why did I go through all that? What are the next two conditions we need to do? We first found where you have the critical values. Okay. Secondly, we need to determine what the sign of the first derivative is to the left and to the right of every one of those critical numbers. Okay? So let's go back here. Here's a critical number. Here's a critical number. We need to know the sign of the first derivative somewhere in here. I would suggest pi 6. Is that okay with you? Yay or nay? Okay. And then maybe here, which I would be maybe about pi halves, don't you think? And then over here, let's pick another value. That would be 3/2 pi. And one right here. And that would be 11/6 pi. Are those values okay with you? Now, why did I choose those? Because these were our favorite ones. Remember? The 6 pi's, the 1/3 pi's, the 1/2 pi's, the whole pi's. I like whole pi's. But all those are your easy to determine. I'm lazy. These are the ones that are easiest to evaluate. Okay? So we know the first derivative, f prime of x, is that. So f prime of pi 6 would be 1/2 minus cosine of pi 6. Now I almost wish I had my circle on the board again. But y'all all drew it down. I could see you writing it furiously when I was doing it, right? Yes, I thought so. Okay. Does anyone remember what cosine of pi 6 was? Want me to draw the circle again? Do I need to? Yay or nay? I think it's still giving people headaches, right? Okay. Anyone got a guess? Cosine of pi 6? Okay, I'm going to do the circle again. Y'all asked for it, you didn't ask for it, but you got it anyway. Okay. Here's 0. This is pi 6, pi quarters, pi thirds, and pi halves. Okay? And you remember for cosine, start at the top and go down. This is 0, 1/2, root 2/2, root 3/2, and root 4/2, which is 1. So what is the cosine of pi 6? Root 3/2. So this will be 1/2 minus root 3/2. Now, frankly, just between you and me, I couldn't care less what the actual value is. All I want to know is the sign of that value. What is it? Negative, because root 3 over 2 is larger than, because root 3 is larger than 1. 1 is root 1, right? So this is a negative. So if it's negative here, that's all I'm interested in. Let's go to pi halves. I already got that down there for you. What is the, I don't know where to put it, f prime of pi halves would be 1/2 minus cosine of pi halves. 1/2 minus, and what's cosine of pi halves? 0. I don't really care what the value is. I want to know what the sign is. What's the sign there? Positive, because 1/2 is greater than 0 in most states, okay? So it's positive here. All right, now what does that make? That means that first derivative is negative. That means the function's going downhill here. It's 0 there. That's what we determined. And it's going uphill there. So what kind of, is that an extremum? What is it? It's a minimum. So we have a relative minimum at, now here's the bad news. It says find those extrema. We know the x value, pi thirds, but we don't know the y value. So we need to come up here and plug that in. F of pi thirds is equal to 1/2 of pi thirds minus sine of pi thirds. Okay? Guess what? They don't find the point. Okay? So I'm not either. Okay? They don't find it. I'm not going to mess with it. Okay? It's an ugly number. Okay? The pi 6 is the first part. Well, it's a messy number. Well, what is sine of pi thirds, by the way? Remember, sine start at the bottom. I'll do sine in red this time, because that was JJ's favorite. Okay? It's 0, 1/2, root 2 over 2, root 3 over 2, and root m1. Okay? So sine of pi thirds is root 3 over 2. Okay? So let me go back to my dark color. Okay, so this will be pi 6 minus root 3 over 2. And again, I'm not really interested in what the exact value is. If I were needing to give that, I would put that as my, right here, I would be pi 6 minus root 3 over 2. I wouldn't bother with figuring out what that value is for y. I would just leave it right there, okay? What I'm interested in, what's the sign of that? Say again? Negative. Because pi 6 is something a little greater than 1/2, and root 3 over 2 is way bigger than 1. Not way bigger, bigger than 1. So that means it's down here somewhere, and that is indeed a relative minimum. Okay? So, in your book, you'll see an actual picture of that, and when x is equal to 0, this is 0, and sine is 0. So, but remember, it's not at 0. So it's going downhill from here and going uphill from there. Okay? Now, let's go to our next one. We know we have a 0 derivative there, so let's do, boy, it's all over the board here, isn't it? Here's my next test point, 3/2 pi. So f prime of 3/2 pi. That's going to be 1/2. Get out of there. Minus cosine of 3/2 pi. Ooh, does anyone know what cosine of 3/2 pi is? Say again? You may have said it right. I don't know.
No, I was thinking out loud. I was thinking where I'm at on the unit circle. So
Yeah. 3 halves pi is at the very bottom. And cosine is the x over r, and what's your x value at the very bottom? Down here.
0.
0. So this is minus 0. Is that positive or negative? Positive. So it's somewhere positive up here, going positive. Your slope is positive there. We know it's 0 at 3 halves pi. I'm not sure where it is. I'm just picking a place. So let's do our next test point, 11 6 pi. Okay? So f prime of 11 pi over 6, just 1/6 pi short of 2 pi, is equal to 1/2 minus the cosine of 11 6 pi. That's pretty ugly, but you can live with it. I told you you could. 1/2 minus. Now what's the cosine of 11 6 pi? Well, 11 6 pi is almost 2 pi, right?
Square root of 3 over 2.
Cosine now. Yeah, you're absolutely right. Square root of 3 over 2. Okay? Is that positive or negative?
Negative.
Yes, it is, because root 3 over 2 is greater than 1/2, because root 3 is greater than 1. It's almost 2, but not quite. Okay, so this is a negative quantity here. So guess what? At our critical point, I think that's a pi thirds in there. No, 5 pi thirds. At that critical point, what do we have? If it's negative on the left, 0 at the middle, and positive on the left, 0 in the middle, and negative on the right, maximum, relative maximum, at, and here's what the book does. They do say at x equal 5 pi over 3. That's all they say. They don't figure the y value. And that's exactly correct. So, that was seemed like a lot of work, but because most of that work was just reviewing trigonometry, okay? Know your trig. That's the point of this. But the actual calculations weren't that bad. So, any questions before I erase this? Okay? Let's see how they do it. Note that f is continuous on the whole interval. That's a good thing to know. I didn't do that, but it is, because this is a polynomial. It's continuous everywhere. That's a sine. That's continuous everywhere. So the function is continuous. I've got to sneeze. Sorry. Sorry. You also awake yet? Okay. Oh, it just knocked Jemanuel out. I saw him go down. Okay. Never mind. Okay. And I did my vampire sneeze, so I didn't spread it to any of y'all. Okay. All right. So, it's continuous everywhere on that interval. And the first derivative, just like you found, was 1/2 minus cosine x. Okay. And so what we do, to determine the critical numbers, set f prime of x equal to 0. That's exactly what you did. And that gave you, they wrote it that way. And then you add cosine x to both sides. They flip sides on you, and that gave cosine x equal to 1/2, just like we did. And then they just magically came up with the fact that it was pi thirds and 5 pi thirds, without telling you how. But now you know how, right? Say yes. Okay. Now, so those are your two critical numbers, unless the first derivative is not equal to, is undefined somewhere, but there are no points on which the first derivative doesn't exist, because this is a constant function. That's a cosine is defined everywhere, so this is defined everywhere. You can conclude these are the only two critical numbers. I sometimes call them critical values, whatever you want to call them. Okay? Just don't name them soup. Okay. So anyway, the table summarizes the testing of the three intervals. They picked different things than we did. They picked pi fourths. That's fine. You could have picked pi fourths. That's to the left of pi thirds. And without showing you that, they say that's negative there, just like we did. So that means a decreasing function between 0 and pi thirds. At pi thirds, it's flat, 0 derivative, and then they picked a point to the right. They did pi. That's perfectly fine. That would have done just as well too. The advantage for that, you only had to do one value to count for both of those. So they did it to the in between those two values, and that first derivative was positive. So if it's negative here, positive there, that meant that is a minimum. And positive here, 0 at the pi thirds, 5 pi thirds, and then decreasing here. They chose 7/4 pi. That's fine. You could have chosen that just as well. That was a negative value, so it's decreasing there, so you have a relative maximum. They love doing tables. If you see it better in a table, put it in a table. Be perfectly fine. Okay? By applying the first derivative test, you can't read that word because it's conclude that f has a relative minimum at the point x equal pi thirds, relative maximum at the point x equal 5 pi thirds. And they showed the graph here. I guess y'all can see it. I can't because my JJ and Jermanuel are in the way, so I'm going to move you out of the way. Ah, there you go. Sorry to be picking you up and moving you by force, but there I did. Okay, so there's your graph. Relative minimum here at whatever value that is. We did find out it was negative. We didn't check this one, but I'll guarantee you it was positive. Okay, they did it right. Any questions? That's your first derivative test. You use the first derivative first, find the critical numbers, either where it's equal to 0 or doesn't exist. Secondly, to find to the left and to the right of that critical value, whether it's positive or negative. If it changes sign, that means you have a relative extreme. Okay? If it goes from negative to positive, you have a relative minimum. Positive to negative, you have a relative maximum. But if those on either side of that critical number had stayed the same sign of your first derivative, like negative, negative, wouldn't be a minimum or a maximum. Positive, positive wouldn't have been a minimum or a maximum. All right. Got it? All right. Beat it to death. Oh, goodness. Don't tell me that's the last slide in the section. We have many more examples to do, so let's do example 3. All right, to go to it? Whether it is or not, we're going to it. Okay. Here's example 3. Find the relative extrema of this one. F of x is equal to x squared minus 4 to the 2/3 power. Okay? And they don't give us any limits on that. So we're going to have to consider the entire real number line. Okay? What you reckon we're going to do first? Anybody?
Chain rules.
I can't hear you.
So we're applying the chain rule.
Okay, well, you're taking a derivative, right? Yeah, okay. Yeah, and you're going to have to apply the chain rule. You're absolutely right there. So let's get it started. What's the derivative of that function?
2/3.
2/3.
Times x squared minus 4
To the
negative 1/3.
negative 1/3 power times chain rule 2x. Perfect. Okay. Now let's clean it up a little bit. and write it. 2 times 2 is 4, so that would be 4/3. And I'm going to write it this way. Times the cube root of x squared minus 4. Okay? Now the reason I did that is a little easier to evaluate. What are we going to do with that? Okay, we either need to find out whether it's equal to 0. Now, is that thing ever equal to 0? The only way a fractional form can be 0 if that numerator is 0. That numerator is 4, and 4 is just absolutely never 0 in this universe, okay? So there is no place where your first derivative is equal to 0. So the next question is there any place where that doesn't exist? What would constitute that thing not existing? Okay, what you say? Yes, exactly, okay? So 3 is never equal to 0, so we're not worried about the 3 at all, okay? But this could be 0 if what's inside of there was 0. So is x squared minus 4 ever equal to 0? Because we know it can't be.
X equals 2.
Okay, say again?
And x equals 2.
X equal 2 certainly would make that. Any others?
-2.
Ah, very good. What you could do is factor that to x plus 2 times x minus 2 and say that can't equal 0, and that would mean x plus 2 is not equal to 0, and, not or, x minus 2 is not equal to 0. And this gives you x cannot equal -2, and this is x cannot equal +2. So there are your two possible values, because those are two places. These are two critical numbers. That can be a C, that can be a C. Those are your two critical values. Okay? There's something wrong with this picture. Oh, that's what's wrong with it. I left off the x. Sorry about that. It's a 4x in the numerator. And none of you caught that. I did that on purpose to see if any of you would catch me, and none of you did. You all lose 15 points today on your final grade. Okay. Yeah, okay. All right. So the question that we got to first, is that ever equal to 0?
It's equal to 0.
Yes, that's equal to 0 when x is equal to 0. So that's also a critical value. So we wound up with 3 critical values here, didn't we? So we're going to need to test them, aren't we? So we need to test something, this first derivative, where it's somewhere to the left of -2. Pick a number to the left of -2. Say again?
-3.
Okay, I want to go, let me see if that's, yes, -3 will work. No, it won't. Well, yeah, it'll work, okay. So let's do f prime of -3. That would be 4 times a -3 over 3 times the cube root of 9 minus 4, which would be 5. I cheated and I didn't want to write it all out. I'm just really lazy today. Okay? Now, I'm really not interested in what the value of that is. What am I interested in?
Whether it's negative or positive.
And what is it? Negative, because that negative sign's up there, right? So therefore, to the left of this, you're going downhill. Here, at this value, and they didn't plug it in, but we could plug that in, couldn't we? We could put a -2 in here. -2 squared is 4, minus 4 is 0, and the cube root of 0 squared is still 0. So we know that point is -3, 0. To the left of -3, 0, you're going downhill. Okay? Now let's pick something in between -2 and 0. Negative 1, is that what I heard? Let's do f prime of negative 1. That will be 4 times a negative 1 over 3 times the cube root of a, where is it? There it is. Positive 1, because 1 squared is 1, minus 4. This will be minus 4 over 3 times the cube root of negative 3. Oh, wait a minute. Can we take a cube root of a negative number? You can't take the square root of a negative number. You can't take the fourth root of a negative number, or the sixth root, or the eighth root. But you can take an odd root of a negative number, and what does that always give you? A negative number. So what's the sign of this one? Positive. You got a negative in the numerator and a negative in the denominator. So on the right side of this, it's positive derivative. Okay? Now we need a number, a volunteer between 1 and 2. 0 and 2. I gave it away because I was thinking of it 1. So let's do f prime of 1. And f prime of 1 would be 4 times 1 is 4 over 3 times the cube root of 1 minus 4. And again, I really don't care what the value is. I'm interested in what the sign is. Negative. So it's negative on this side. Okay? So this looks like this has to be a relative minimum. This looks like this has to be a relative maximum. Okay? I need one more volunteer to be a test point. Something to the right of 2. 45. Okay, I want, that sounded like, let's see, I think that was, huh?
Sounded like a challenge.
I couldn't hear.
It sounded like a challenge.
Yeah, it sounded like Andy to me is what I was trying to say. And therefore I want Andy to calculate what, yeah, you stepped in it, didn't you? Okay, let's do f prime of 45. That's certainly to the right of 2, I'll give you that. That will be 4 times 45 over 3 times the square root of 45 squared minus 4. Now, Andy cares about what the value is, so I want him to calculate it. But I don't care about anything but the sign. And what is the sign of that? Very, very, very positive. That's somewhere up here, almost straight up, okay? So, we know that this is also a relative minimum. Even though Andy chose something so bizarre, you can still say that's true. Because you see, this obviously is positive, and 45 squared is a lot bigger than 4, so that's going to be positive too. Oh, that was a cube root there, not a square root. Okay. Good deal. So even with a weird number, all we're interested in is the sign. So we have relative max, relative min at -2. X equals -2. A relative maximum at x equals 0. And a relative minimum at x equals 2. Okay. Let's see what they concluded. And they actually calculated this one. There was a reason they didn't calculate the other one. This was, why did I put a -3 there? That's a -2. Okay. Again, y'all let that slip by, didn't you? Okay. You weren't paying attention. Okay. -2, 0. When you plug in a negative 2 here, you get a 0. This point here at 0, plug in a 0 here. F of 0 is equal to 0 minus 4 to the 2/3 power. Well, that's going to be negative 4 to the 2/3 power. What in the world is that? Does anyone know? How do you do that? What does it mean to be to the 2/3 power? Does anyone know? Help me, somebody. Well, I'll give it to you this time. You start with the negative 4, and you can go either way you want to. You can either first square it, that gives you square 4, negative 4, you get 16, and then take a cube root of 16. I don't know what it is, but it's going to be the cube root of 16. Or you could have taken the cube root of 4, or negative 4, which I don't know what that is, but square that. This was easier to do this way. But that some number, can you give me two integers, one on either side of it? This is greater than 2 because the cube root of 8 is 2, right? Yay or nay? Okay. And it's less than 27, right? Because the cube root of 27 is 3, so it's some number between 2 and 3. Okay? So what they give as their answer, I bet, is 0, the cube root of 16. Okay? And that's a minimum, or maximum. This is the minimum. And then over here, when you plug in a 2, what do you get there? F of 2. Anybody? Zero. Okay. So this will be 2, 0. Relative minimum at negative 2, 0. Relative maximum at 0 cube root of 16. And relative minimum again at 2, 0. So let's see what, yeah, that's how they did it too. And if you look on the graph in your book, if you got your book, you can see that the cube root of 16 is somewhere between 2 and 3. They put it almost midway through between those. I would have thought it would be a little bit closer to 2, but I'll let them get away with it. See how that works? And do you also see how those where the derivative does not exist works? Those are called cusps. It comes down really sharply from one side, goes up really sharply on the other side. Nothing smooth about that. Not at all smooth. Continuous, yes, but not smooth. Okay? And these functions don't have to be. All they have to be is continuous, and they're continuous there. But at the plus or minus 2, anything but smooth. That's why the derivative does not exist. All right? Beat that one to death. Let's move on to, I meant to say that you need that up there any longer, but I forgot to. I was trying to get it out and I couldn't think. All right, we got plenty of time. Let's move on to example 4. And example 4 is one of these that you can go to larsoncalculus.com and see an interactive version of this type of an example. So if you don't like the way I do it, go there. Okay? If you let me know you don't like it, no, never mind. So here's your function. F of x is equal to, we're finding the relative extrema of x to the 4th plus 1 over x squared. All right. Ooh, yuck. Okay, what do you think we're going to do with this one? Take a derivative is a good answer. Do you want to do anything before you take a derivative? Maybe you don't, okay? If you were going to take a derivative, what rule would you use? The quotient rule. And I can tell you love the quotient rule. I don't particularly. So I'm going to be a little bit lazier than you are and rewrite this as x to the fourth over x squared plus 1 over x squared. Is that legal in most states? Yay or nay? Okay. Now, what's x to the fourth? X to the fourth divided by x squared. What would that be? Okay, I'll do it this way. X to the fourth means x times x times x times x. X squared means x times x, right? What do you have left? X squared. The easier way to do that is subtract your exponents. That would have worked too. All right. Now, I'm going to do something else here. I don't like having an x in the denominator when I'm trying to take a derivative. So I'm going to rewrite that as what? X to the, I thought I heard someone whisper it, -2. Okay. Now, I want to take the derivative of that. Are you okay with that? What's the derivative of the first one? 2x. What's the derivative of the next one? -2 times x to the subtract 1. -3. Now, JJ's still back there doing the quotient rule, by the way. Okay. No. Okay. See, I'm a lot lazier than JJ is. Okay. Now, what are we going to do with that? I think I'll rewrite it to be 2x minus 2 over x cubed. Okay. Now, the only reason I do that, it may be easier to see something. What are we going to do with that derivative? Okay. We're going to investigate where it's equal to 0 and later where it doesn't exist. Okay. Now, to do that is equal to 0, what would you do first? Well, maybe I shouldn't have written that. What would you do first? What would the minus sign suggest? Add 2 over x cubed to both sides. Now that doesn't look a whole lot better. That gives you 2x is equal to 2 over x cubed. No, that's not a, yeah, that's a cube. Now, what do you not like about that? Well, you got x on both sides, okay? But what you don't like about where one of those x's is? It's in the denominator. So how do we get it out of the denominator? That's a division, so we multiply by x cubed. But you do that to both sides, of course, don't you? And what does that give you? Anybody? 2x to the fourth is equal to 2, right? So, I'll divide both sides by 2 and have x to the fourth is equal to 1. Now I ask myself, what values of x can you have that when you raise it to the fourth power, you get 1? Okay, that certainly works. X equal 1 would be a 0. And a -1. Very good. Those are the only two places where your first derivative is equal to 0. Okay? Now the question is, and these now are critical values, so we'll name them C also. Not just that, X, but C. Now we now have to ask ourselves, where is that first derivative? Doesn't exist. Focus on this part. Where does that not exist? Yes, when x is equal to 0. So x cannot equal 0. That means that x equals 0 is a critical value. That's also a critical value. So now we have 3 critical values. All right? -1, 0, and 1. So what we've got to do is pick a value to the left of -1. Say again? Andy doesn't get to answer, by the way. -2. So f of -2, f prime of -2 would equal, that's bourbon and Coke this early in the morning? My goodness. Okay. All right. F prime of -2, we'll cut out the seriousness here. 2 times a -2 minus 2 over -2 to the 3rd power. Okay? And this would be what? 2 times -2 is -4 minus 2 over, and what's -2 cubed? -8. Okay? So that looks like that would be a -4 plus 1/4. Right? Now I can figure out what that value is, but I really don't care. What do I care about? It's negative. So here we have set up somewhere here that I'm going to draw a little number line here. Here's our -1, there's our -2, there's 0, there's 1, and there's 2. Guess what? We're going to use that. I'm not going to let Andy have a choice here. Okay, here at -2, you have a downward slope. Here we have a 0 slope. I may be in the wrong place. So let's pick a number, a value between -1 and 0. Ooh, yeah. Fractions. What you choose? -1/2. Let's try that one. F prime of -1/2 will then be 2 times -1/2 minus 2 over a -1/2 cubed. Okay? Anyone tell me what 2 times -1/2 is? -1. And then a minus 2 over, anyone tell me what -1/2 cubed is? -1/8. Perfect. Okay. Now can anyone tell me what, now this will be a -1. When you divide a 2 by a -1/8, what's that the same as? Oh, you do? Ever hear of inverting and multiply? Dividing in fractional form? Okay, so what would that give you?
-16.
Okay, except you got a minus here, so let's make it a plus 16. I do know what value that is. What is it? Plus 15. I don't really care, except I know that's steep like crazy there. Okay? So, we have a relative minimum at -1. Okay? We'll come back and figure out what the value is in a minute. Okay? Next, okay, let's go on to plus 1/2. That shouldn't be too bad. F prime of 1/2 is equal to 2 times 1/2 minus 2 over a 1/2 cubed. So that would be a 1 minus anyone want to hazard a guess? I can't hear.
Be negative.
Yeah, it's going to be negative because this is a 16 again. It's the same numbers as before, but just without one of the minus signs. So it's minus 2 over 1/8, which is minus 2 times 8 over 1, which is minus 16. So this is very, very negative there. So guess what? At 0, you have a max because it's negative on the left, positive on the left, negative on the right. Okay? And we need 1 point to the right of 1. Not you, Andy. 2. Okay, we'll go with 2. All right? That would be 2 times 2 minus 2 over 2 cubed. Right? There's your F prime. So this is going to be 4 minus 1/4 again. Okay. Whoa. And that's going to be, I don't care what the value is, though it's pretty easy to get. What's that going to be? Positive. So here we have another minimum here. We have a 0 here. We have an undefined here in the middle, but we have a 0 there. So this is another minimum here and there. Maximum up there. So now let's go to figuring out what the actual values are. So f at -1 is going to be -1 to the 4th power plus 1 over -1 squared. Anyone want to make a guess what that is? Look again. Okay, let's see. -1 to the 4th is 1 plus 1 is 2 over, what's -1 squared?
Oh, it's a square. Okay. So
1. So 2 over 1 is 2. So this is the value down here, a minimum at -1, 2. Now, that doesn't look like much of a minimum. Yep, it is. That's fine. Perfectly fine. But here we have a problem, don't we, Houston? We should have seen this ahead of time. Because remember, the function had to be continuous. It's not continuous at x equal the function itself. What can x never be? 0. So we shouldn't have done any of this mess with 0. We didn't need to do that because it's not continuous there. This doesn't work if it's not continuous. Okay? So this is a vertical asymptote there. You don't have any continuity there. There is no value at x equals 0. So forget about that one. So this is not a maximum there. It's none defined there. How about down here? That was another minimum. Let's figure out what value that is. F of 1 is equal to 1 to the 4th plus 1 over 1 squared. What's that? I think y'all are making JJ do all the work here. Someone help him out. 1 to the... It's what?
said I got lost. Where do we get?
Okay, here we are. It's ugly, but it's there. 1 to the 4th plus 1 over 1 squared. Plugging into this. 1 to the 4th is? Is what? The answer is 2. So this one down here is another minimum at 1, 2. So you had a minimum at -1, 2, and another minimum at 1, 2. no maximum, no relative maximum, because the function wasn't defined at 0. We should have eliminated that at the beginning so we didn't have to do any of this mess here. Then we still would have had to have done a -2, -1/2, +1/2, and positive. We still would have had the same test points, but we wouldn't have even fiddled with the possibility of a maximum at 0, because it doesn't exist there. All right, and you can look in the book, and this does come down something like this, and comes down something like that, with the minimum at -1, 2 on both sides, and +1, 2. All right, that was example 4, using the first derivative test. There is a technology thing at the bottom of the page there that leads you to a very ugly situation, but I'll let you read that. It says the most difficult step in applying the first derivative test is finding the values for which the derivative is equal to 0. No kidding, okay? And the values, for instance, the values for x in the problem they give there are awful. That's an embedded square root inside of square root, you know, a terrible mess. Okay. Now, we've still got a few minutes, right? Can I erase this one? Most of you don't care, do you? Okay. So, I will erase it. Okay. And let's do example 5, top of page 226. Neglecting air resistance, the path of a projectile, looks like a jump shot to me, that is propelled at an angle of theta is y, that's going to be the height, is equal to -g. For those who get into your physics later, you'll recognize that as being the acceleration due to gravity, times the secant squared theta, one of my favorite for expressions of all time, divided by 2 times the initial velocity squared, times your x squared, which is your horizontal distance that it's traveled, plus tangent theta times x plus h. All right. And this is good for all thetas in between 0 and pi halves. Now, I have to ask some of you who are better at basketball than me, do you usually want to keep the ball going between 0 and pi halves, in other words, ahead of you, or do you want to shoot any shots behind? Well, I don't want to. I might have a better chance of hitting the basket then, but, you know, the only way I could see to do that, and I think Houston could do it, but I couldn't, is dunk behind your head. But I can't even come close to that. So that's the only way I could see doing that to be. So yeah, let's keep it between 0 and pi halves. Okay? Where y is the height, x is the horizontal distance from where you shot. G is acceleration due to gravity, v0 is your initial velocity, and h is the initial height. That's the height when it left your hands, okay? And on a good jump shot, that guy looked like he probably was more than 6 feet tall. His arm length is probably another foot above him, and he jumped maybe a half foot off the ground. So yeah, that's pretty good height there. That equation is derived in section 12.3. I can't wait. Let g be 32 feet per second squared, which means you're in the U.S. customary. This is 32 feet per second squared. Okay. V0, your initial velocity, is 24 feet per second. That's a pretty hard throw, it seems like to me. And the height is 9 feet. Okay. I was guessing somewhere about there. H is 9 feet. What value of theta will produce the maximum horizontal distance? Okay? Now, what I'm going to do is ask you to read through this problem. Plugging in the numbers is no problem at all, okay? But then you get down to a really nasty looking trig function. It has secant squared theta and tangent theta in it. You need to convert that secant squared to a tangent squared, and it comes out being a really big mess and a half, and I want to pick up reading in near the last paragraph there. At this point, you need to find the value of theta that produces a maximum value of x. Applying the first derivative test by hand would be very tedious. That is the biggest understatement that this book has ever written, okay? So using technology to solve the equation dx d theta is equal to 0, however, eliminates most of the messy computations, so the result is about 0.615 radians, or about 35.3 degrees. I know that's what Houston was thinking when he shot that jump shot, right? That's exactly the angle I need for that. So anyway, they made you go through, or wanted to make you go through, all manners of ugliness to get to the point of saying you can't really do it very easily analytically, okay, by hand. So go and use some tools. So I'll let you do that one. If you have the tools, go for it. That finishes 4.3. Any questions on 4.3? Okay. There's a concept check here. Always think through that. Make sure you understand it. Then the first problem, number 3, you can find at calcchat.com. Any of the odds 5 through 9 you can find at calcchat.com. 5 is at calcview.com. Any of the odds 11 through 21 are at calcchat.com. 13 is at calcview. Any of the odds 23 to 55, they're all at calcchat. 25 is at calcview. Do some of those. Any of the odds 57 to 61, all at calcchat. 57 is at calcview. Any of the odds 63 to 69, they're all at calcchat. 71 should be at calcchat. 73 through 77 should be at calcchat. You can explore doing 79 or 81. They should both be at calcchat. And 83 and 85 should both be at calcchat if you want to look into those. 87 should be at calcchat. 89 should be at calcchat. Well, I would say, well, yeah. 91, well then, from there on, you choose any of the odds from 91 through, goodness gracious, 95. They should be at calcchat. 97 or 99 should be at calcchat. 101 should be at calcchat. They don't have enough problems here, do they? 103 or 105 should be at calcchat. There's some true false, 107 through 111. They should be at calcchat. And then I know some of you want to do a few proofs. 113 through 117 odds should be at calcchat. If you want to look at the section project on 4th degree polynomials, you certainly can. It's certainly not required. Any questions? 4.3. All right. So what I'm going to do then is scroll out of this and hit here and discard that. And when I do this, y'all are going to lose the screen. And it's 11:36. We have 4 minutes. Let's at least get introduced to 4.4. So hang on. I'll be right back with the screen. I'm still here. So I need to go now to this screen. Okay. And I'm going to share that screen with you. There we have it. Y'all can see it now? Yay or nay?
Yes.
Okay. Go from current slide. There we go. We just did 4.3 where the guy was shooting the jump shot. So let's move on. The chapter hasn't changed. I can't read it. It's just application of differentiation. Okay. And 4.4 is concavity, which we haven't talked about before, and the second derivative test. Okay. So let's see what in the world we're going. Our objectives here are to determine the intervals on which the function is concave up or concave down. Now you did this, you may not have called it this, back when you did parabolas. Parabolas either opened up or they opened down. Okay? So that's what we're talking about. We'll find any points of inflection, which is another situation here, on the graph of a function. We'll apply the second derivative test to find the relative extrema of a function, which actually is a little easier than the first derivative test. You just have to take a second derivative. But y'all like doing that part, right? Say yes. Okay, good. So let's first look at concavity. You have seen that locating the intervals on which the function f increases and decreasing helps to describe the graph. In this section, you'll see how locating the intervals on which the first derivative increases or decreases can be used to determine where the graph is curving upward or curving downward. Okay? So here's a definition of concavity. It's on your page 231. Let f be differentiable on some open interval I. The graph of f is concave upward on that interval when f prime, the first derivative, is increasing. Okay? F prime is increasing. We didn't mean f is increasing. That just means f prime is positive. F prime is increasing. The first derivative is increasing on that interval. It's concave downward where the first derivative is decreasing on the interval. Not negative, but decreasing. Okay? So that's a little bit of a change here. Well, how can you tell where the first derivative is increasing and where it's decreasing? Take the second derivative. If the second derivative is positive, the first derivative is increasing. If the second derivative is negative, the first derivative is decreasing. Just like we did with the function, taking the first derivative, we take the movement of the first derivative based on the second. So here is a following is graphical interpretation of concavity is useful, they say. If f is differentiable on an open interval I, now what does that mean? It means it has to be both smooth and continuous. For it to be differentiable on the open interval I, it has to be smooth and continuous. If the graph is concave upward on I, then the graph of f lies above all of the tangent lines. Now, I never think of whether it's lying above or below a tangent line, but that is indeed true. Because you see here, this is concave upward. It's bending upward. I'm going to get my pen back. Okay. It's bending upward everywhere. That means the first, I didn't get it, did I? Okay, there we go. The first derivative is always, the tangent lines are always below the curve. Okay? That means your first derivative is always increasing. The tangent line is increasing everywhere. Even though it's a negative tangent line here, it's still getting less and less negative till it reaches zero and then more and more positive. So it's increasing everywhere. Okay? It's concave downward if the tangent line lies above the curve at every point. Okay? And you see that indeed is true, because here, even though the tangent line is positive here, they don't have it drawn here, but the slope is getting less and less and less and less, so the first derivative is decreasing everywhere there. It starts off being positive, but gets less positive until it goes to zero, then more and more and more negative as it goes. So that's one way to look at concavity. The better way is the first derivative is increasing, is concave up, and if it's decreasing, it's concave down. All right. Whoops, I think we just ran out of time, didn't we? Okay, not enough exercises. We didn't do any exercises here, so not enough for any homework exercises, but you got plenty to do on 4.3. So, any questions before we leave?
Yes.
Was there one?
Yes.
Yes, what was it?
How do you check your Blackboard messages on the mobile device? How do you check your mobile device?
Can anyone answer that? I don't ever do Blackboard on my mobile device.
All you do is click announcements. And that's what I
was talking about the messages.
Yeah, I was looking for the test on the Blackboard mobile.
He needs the messages,
Okay,
not the announcement.
you need to. Okay, is the question how do you get to Blackboard on your mobile device? Is that the question?
The question is how do you get to the messages on your mobile device? Because I'm on the
Okay,
course.
are you in the course on your mobile device?
Yes.
Okay, now on your mobile device, do you see a set of words at the top when you're in the course? Or symbols anyway? Do you see that little symbol that looks like an envelope? There's one symbol that looks like a page with writing on it. There's another symbol, I can't remember all those symbols, but one of those symbols at the top looks like an envelope. Do you see it?
No, I only see the course content, collaborate, and discussions.
Okay. Can you hold your device up to the camera?
Yes.
I don't know if I can see it. Whoa, that's a nice device. Okay. It's too much glare. I can't quite make it out. Okay. Okay. If you scroll on down from there. Oh, wait. No, I'm sorry. Okay. Go back up. Okay. Yeah. Okay. Now, usually in that block there.
Does not look like you can access messages through the app.
Huh. Okay.
Did you just try to look at the test?
Yeah.
Yes. So, see where it says, course content? Yeah. You click that.
Okay. What I'm going to do. Okay. You're going to lose my screen, but I'll be right back with you in a minute. Okay.
It looks like that's just one of the flaws in the app versus the working on desktop.
Minimize this. I'm going to lose you for a moment.
I have a question.
Yes, what's the question?
When you post in the messages, I thought the Blackboard it would send us an email, but it didn't.
Okay, now here's what I've heard. This new Blackboard, whatever you call it, Ultra, that if you try to have it send the emails, it loses students, and I don't know why. I've been told don't do that, and I thought I've had students tell me that they did get emails, but that's the problem. Sometimes they give you emails and sometimes they don't, and I don't know how to control that. What I'm trying to find is this. Okay. It's going to take me a few minutes to log in. You probably can't see what I'm doing, but I'll be there in just a minute, I hope. My computer's sort of slow. I've got so many things open. Okay.
Yeah, the only email I've ever gotten regarding Blackboard messages is one at the end of the day that says you got a message. You still had to go into Blackboard to be able to look at them.
Right. And see, that's the same message as everything, and I don't know why it sends that one, but not all of them. I just don't know. Let me pull this up, and then I'll be right with you. Okay. All right. Zoom. Okay. Need to go to Zoom. Come on, Zoom, pull up here. Here we go. Okay. Return the meeting. The trouble is I'm running out of time. No, I guess it's here. Okay, share screen. I'll be with you in just a minute. I think it's... Screencast-O-Matic. I just opened it and now I can't find it. Do more. Share screen. Let me try this one. That's the closest I can see to. Yeah, there it is. Can you see what I've got here? Okay. Now that looks a lot like yours, right? Except you don't see these things at the top. Okay. Now, can anyone think of any way? What kind of device do you have?
I have an iPad.
iPad.
I don't think it matters on the device. If you're using the app instead of going to the website, you're going to have problems with it.
Okay. But you can, okay, doesn't the app only get you to the, say, Blackboard? What?
The only thing that the app has is activity screen, courses, organization, grades, pages, settings.
So yeah, the app is definitely limited.
Okay. Okay. I'm going to read through some of these. Content is this first one. The next one is calendar. The next one is, and I'm in content now. The next one's discussions. The next one's gradebook. And the next one's messages. Do you have any way of getting to your gradebook?
Yes, but that's a different tab.
How do you get to your gradebook?
There's a tab for that in the app.
There is an
There's
app
not a
for
tab
that.
Messages or announcements in the app.
And there's an announcements app.
There's no announcements and no messages in the app.
I downloaded the PDF, and things I want to just put it,
Okay. Here's what I'll do then. I will go into announcements and load the second test on the announcements page. That's an you can get to the announcements, Houston? Say again?
I think so. I think the announcements pop up.
Okay. So that's what I'll do. I'll start posting all the tests on both messages and announcements. Will that work? Okay. Now it's probably going to be late tonight or maybe even Friday before I get to it because I've got classes till 6:30 this evening. Then I've got a phone call with the dean and the associate dean. Then I've got 4 classes tomorrow that take until 6 o'clock. And then on Friday, I finally have some free time. I might be able to get to it tomorrow evening, maybe even this evening, but it might be a while, but I'll get it out there and you have all the time you need to do it. Okay? Before the end of the term, of course. Is there another question? Okay. All right. Well, I'm going to stop share because it's probably about to cut us off anyway. Okay? So we'll see you on Monday. I'll try to get that test out there on announcements. Okay? All right. Glad to.
But yeah, Houston, there's definitely some things that you cannot do through the app.
What's that?
I was just telling Houston that there are definitely limitations to trying to use the app through a device.
Is that right?
You have to go to the desktop thing to be able to access everything.
Okay. I'll try to spread this word to everybody because I didn't know that was a situation. So thanks for telling us. Okay. We'll see you next time.